So it's a good afternoon and welcome. We're here this afternoon to talk about forecasting with the Microsoft Time Series data mining algorithm. My name is Peter Myers. I'm a business intelligence expert. I'm an all-rounder, and data mining often catches my attention, and I look for opportunities where I can do much more on a project by delivering back to the business some insights and perhaps even predictions on the data that they're currently collecting and managing. Brief background about myself. I don't work for Microsoft. I'm in fact a SQL Server most valued professional. I have been for the past 8 years. I've traveled from Melbourne and I spend a lot of time these days in training, education and awareness around Microsoft Business Intelligence products. Feel free to connect with me on LinkedIn, or if there are any questions that I don't address during this session, and I would hope that I do, by the way. My style of delivery lends itself well to interactivity, so feel free to inject a question as and when it arises. What we're here to discuss today is what data mining is about, but specifically machine learning processes concerned with forecasting of time series. I'm going to give you a whole set of demonstrations that show you what you can achieve from working with Excel, working with Visual Studio as a developer, working with Script as an administrator, and maybe even as an application developer working with code. We'll look at how we can tune a time series model, and we'll describe some business scenarios that could inspire you on how you could apply these techniques. So I thought a good place to start would be the very history of forecasting. Take a moment to absorb this one. A favorite artist of mine from Melbourne. So an interesting sense of humor here. So from the dawn of time, cavemen themselves were thinking about what could be in the future. Perhaps in more recent times, we see businessmen attending the services of these folk. I'm aware that certain political leaders have been known to get war advice, I think, by using clairvoyance. More recently, we see mollusks enter the domain. And with the freakily accurate predictions that were made in the last World Cup. So we're not really here to talk about these techniques. I'm sorry to disappoint anybody. If you are interested in these, they're probably another session, most likely in a completely different conference. Because here, we're here to talk about information technology and how sound machine learning techniques can guide us and provide us with some concept of what could happen in the future based on what has happened in the past. So let's put that definition forward, that the time series forecasting is about developing data mining models to predict future values based on previously observed values. So if you ever find yourself in the situation where you need some idea about what could be happening, you might look towards a clairvoyant or a mollusk or even your own gut instinct. But perhaps it's better to support your gut instinct with some scientific reasoning and then make a choice, or maybe blend the two together. Here's an idea of what we could achieve. There's sales, the cyclical pattern that's happening over a couple of years, and via a detection of patterns within that data, we can put forward what could happen in the future. Let's see how it happens. So there's no prerequisite that you have any background in data mining. Let's start with the very fundamentals. When it comes to producing a data mining solution, first of all, you need to understand the business problem and then design a model to help you with that. And a model is defined in terms of an algorithm that is responsible for detecting patterns. You have inputs and outputs. So in a time series, your input's going to be sequences of time and snapshots like sales values that have occurred each month. We then process the model. That means taking carefully prepared data, our sales history, and then it gets passed through the data mining engine that is responsible for detecting and then storing the patterns in the model. So when you think of tables in relational databases, it's obvious, tables store rows. In the data mining world, models store patterns, and these become the queryable resource either for exploration and information discovery, or, as our purpose is in this session, for prediction purpose. When it comes to predicting them, we have the query stage. We could take data and pass it in, and the engine will use those patterns to come out and say, these are the future values. And we'll work through this process a number of times in this session. So, the big picture, time series with analysis services. Let's take the big picture and say, well, analysis services is a product concerned with data modeling and data mining. There are, in fact, two components. And most of us, when we hear about analysis services, we're referring to it as far as cubes or tabular models. Its lesser-known brother is the data mining engine, and it comes with 9 algorithms. These allow you to discover patterns and to perform predictive analytics. We'll focus on specifically one of the 9 algorithms, which is the time series algorithm. So be aware that much of what I've got to present today, I could have talked about 8 years ago. Nothing much has really changed. And so we first saw the time series algorithm delivered with SQL Server 2005. What had changed in the next release with SQL Server 2008, we still have the same algorithm, but there are actually 2 machine learning algorithms under the covers. We'll talk about these both. ARTXB for cross-series prediction and the ARIMA. The algorithm then detects patterns and allows us to predict future steps within a time series. So let's start with a demonstration of how it could work in the most basic form. Here I am in Excel with a set of data, I guess, coming from an ice cream company. We have monthly values for sales, 2 series here, strawberry and chocolate. And what I'm going to do is take this range of data and make it an Excel table. And when I do this, we'll see that this Analyze tab highlights. This is because I've downloaded and installed the SQL Server data mining add-ins. And this particular add-in enables the mining of data in a table. So if you have a table in focus, you have the Analyze tools. Now be aware that Excel doesn't have a data mining engine. It does require analysis services somewhere on the network. And so as the administrator, I would switch across, connect to analysis services, and I'm going to go ahead and create a database for the purpose of the mining activities that will take place from Excel. So this is simply a database, and I'll point out also, as an administrator, that I have configured here a property that's called Allow Session Mining Models. The reason for this is that this tool uses session objects. What that means is for the lifetime of a session, we can create, and then when the session dies, so do the objects. And that's actually quite fitting for time series, because often when you've achieved the predictions, that model may not be worth much more when you move to the next step in the future. You then create a whole new model based on the current values and the history that you've got and produce an entirely new model. So with that database now available, here in Excel, I'm going to connect to that instance and to the session mining database. And now with the table selected, of all of the commands I have here, the one relevant in this session will be to perform forecasting. And what I like about this add-in that makes it really approachable to the average Excel user, it doesn't even mention data mining anywhere within the user interface. It's simply which columns do you want to forecast, how many steps into the future are you looking for, is there a timestamp, and the periodicity. And we're going to talk about this one. It's actually quite critical that you, where appropriate, configure this. And perhaps as a Excel user that's not a data mining specialist, this might throw them, but I guess they'd work out that their data is monthly, and so monthly would be the right selection to make. Simply by clicking Run, it sends commands across to that session database to create session structures, models. It copies the data and passes it in. The passing in is really a process that involves the detection of any patterns, and then it returns with a query result that first of all extends the table. I don't know why I have this empty row. Let's delete that. So effectively, there's the next 6 months that we might expect, and then it adds a bonus here with a chart showing us the projected values that could happen. So that's the very first introduction for those that are looking for an easy way to get involved with forecasting. Just collect your data in Excel, assemble it as a table, install the add-ins, and mine direct within Excel. With a focus on the first of the 2 algorithms, the autoregressive tree with cross-series prediction. This was the first algorithm that was delivered in 2005. What's pretty cool about this algorithm is the cross-prediction capability. That where you have multiple series, there could in fact be influence across them. For example, chocolate sales go up, strawberry sales may go down, and so it may detect patterns between the series themselves. This concept is unique to Microsoft's implementation of the autoregressive tree. It's considered to be a reasonably accurate algorithm for short-term prediction. So the way that it works is it uses past steps, and when it predicts the next step, and then the next step, it may, in fact, at some point start using predicted steps. So it's predicting based on predictions, so very quickly it becomes unstable. So we use it typically for short term, the next 1, 2, 3, 4 steps. Let's take a look at it in demonstration. So I'm going to create a couple of really basic, simple models to show you how it works. The first one will be, let's call it simple 1. And I'm going to have a single series of just value, and I'll begin with 2, and then I'm going to increment each step by 2. And so if I copy all this the way down here, I end up with a series, and now I'm going to use the second add-in available to you in Excel. This is the data mining client tools. This is actually a very, very powerful set of tools available to not your average Excel user. It would typically be someone that's experienced in data mining. It supports, here in the first group, features to prepare data. We then have the data modeling capabilities and advanced here to control to a finer degree. We have accuracy and validation testing, and then we have the usage of the model right down to querying, with the ability to bring query results back into Excel. So this is typically considered to be the life cycle of a data mining project. For my demonstration now, I'm going to create a forecast model based on the range of data selected. And by the way, it could come from an external source as well. And then the timestamp, well, I don't have one, which is usually not the case. And then here in the parameters, each algorithm has its own parameters that allow tuning and controlling what it does. So for the time series algorithm, the one that I'll point to here is the forecast method. And to demonstrate the cross-series prediction, I'm going to limit it to only use cross-series, not to use the ARIMA component at this stage. What will be the name of the structure? So the way that it works with the data mining projects is you have a structure that consists of all of the columns of the data that you have, and structures then allow reuse of metadata and data. And it's quite common in a data mining project that you may have multiple models associated to the single structure. So it just avoids duplication of data and effort. Structure is named simple 1, the model will be named simple 1. I'm going to browse the model and I'm going to enable drill through. And by the way, for time series, you must always enable drill through. This feature works differently for different algorithms, but for the time series algorithm, it's where it actually stores the historic cases, which is what it needs at query time. So if you don't enable drill through, you don't have any predictive capabilities. I could switch on the session option, but I'll leave it persisted. Creates the model, takes the data up, and here is the browsing experience. And as we'd expect, there's this linear projection. And as I predict into future steps, it's just incrementing by 2. But what's going on under the covers is the regression tree. And it's found here that there's a formula, which is this. Your value is going to be 2 plus 1 multiplied by value minus 1, the previous step. And then 0 multiplied by value minus 2. I don't know why it says that, but ultimately there's a very simple formula showing you just add 2 for each step. Okay, let's move to a simple number 2. This one's more a bit of fun. What if we use random numbers to mine? Give me a random number between 0 and 100, and let's produce a series of these. And then I'm going to copy and paste this as values, so it doesn't change. Let's see what happens when we mine a random set with exactly the same configuration. And this will become my simple 2. And as I go to project, what we end up getting is this static line. And let's understand why. 40.833, I'm guessing it's the average. It found no pattern, as you would likely expect from random numbers. And so while it may not appear as interesting, sometimes you do discover data's random, and data mining can tell you that, and that's the end of the story. No patterns can be found. Okay, this set is random. So at 40.833, the average is in fact that. You can see down here on the status line for Excel, that range of data sits at that average. So let's move up to some more interesting sets of data that will involve cross-prediction capabilities. Here I have a single year of data giving me monthly temperature and sales. And we suspect that there's some correlation between them. If temperature goes up, sales go down, or the inverse. So I'm going to forecast this range, and this time I do have a timestamp, which is months, so I don't need to mine it. Turn on the parameters again to limit this to cross-series prediction. And so what we discover in this example is there is a distinct peak somewhere within the middle of the year for both temperature and sales. And what this would allow us to do is discover what sales are doing. Now, this is a little suspect when you see historically we've hit a peak of around 220, and yet 17, 18 steps into the future, it's not ever hitting there. So there is a minimum amount of data, and typically it would be 3 cycles. So if we have an annual cycle, we would probably prefer that there's going to be 36 steps, so it can definitely find that. I'll show you this feature here that shows deviations. All right, the bigger the deviation, the more unstable and less reliable that prediction is. So very, very quickly, it's not worthwhile. We'll talk about this in a little more detail. So let's move on to the next one where I have 2 years worth of data. And I'll introduce an important algorithm parameter at this point, which will be the periodicity hint. So you saw in the first demonstration that the add-in had said, well, what's the description of your data for time? And that's really a configuration of this property here. By default, it thinks every step is within its own cycle, but for seasons or months within a year, we would set the hint at 12. And the way to interpret this is to think how many cases before I'm starting a new cycle. Every 12 cases starts a new cycle. This is what you'd specify. You could also specify cycles within cycles. If there were quarterly cycles within the year, you'd have 12,3. Very important hint where there is seasonality within your data. This will become XP2. And now we have a much more reliable and stable result, and with lower deviations. Ultimately, what we see is the formula is giving us that in order to predict sales, this is the formula. It will equal minus 42, and then you can see here, let's take a coefficient against the sales from the previous step, and then temperature from 6 steps in the past. So it's using that history in order to find the best fit pattern. The last one. Here I have 3 years worth of data. And I'll configure this the same. And we see something going a little wrong with sales down here, whether there's a manufacturing issue or a supply issue. Something's out of whack. What's going to happen then when we predict from this? Interestingly enough, it stops. And there's some governors within the model itself that says it's so unstable, I'm not even going to give it to you. You can override this if you want, okay? But what do you think might be a better thing to do if you encounter this realistic situation? That something went wrong with production.
Remove the outliers.
Yeah, these are outliers. So you're more than entitled to come in here and say, well, let's actually play with the data. When I say play, I mean responsibly go in there and fill in and substitute with not what you'd like it to be, but what you think it would have been. And then you could keep the model on track. So there's several approaches you could take here. Maybe discard this and use the previous 2 cycles and continue using those patterns into the next year. Or if you think that there really is valid value to use the 3 years, go ahead and massage the data. All right, so there's a lot to be said for the preparation of data in advance of mining. The garbage in, garbage out principle applies. If you're going to have this type of, it's not necessarily garbage, but it's skewing information, you need to address it. You can ask a question. What is it?
So this is all very simple when you have one data point per month, but if you've got multiples, does it take into account some outliers and kind of exclude those?
So the question is about when you say you've got lots of series or lots of data points or different granularities of data points?
Lots of data points.
Lots of data points. Lots of data points across time. Okay, so what you'd need to think about is that, are you looking for short-term or long-term projection?
Yes, short-term.
If it's short-term, okay, typically it's not going to use anything, let's just say it's monthly data, or let's just say you have daily data. It would be unusual that it would go back 400 steps to look at something from the last year. It would typically stabilize a pattern at a point where it wouldn't need that. So you might well find that that history isn't so relevant anyway. For ARIMA and for the integrated moving average and the smoothing, the longer-term data might be more interesting. Okay, so it depends on your needs. All right, just depends. What you'll discover, as you've seen with those equations, it went far back, I think, as -12 at most, even though it had 36 steps in its case history. All right, so just take a look at what it finds, and you'll find that it typically won't reach that far back. The second algorithm then, the autoregressive integrated moving averages, this was added in 2008. What this means is by default, when you're using the time series algorithm, you're actually getting a blending of the two together. This is considered a more accurate and stable algorithm for long-term prediction, but it does not support cross-series predictive capabilities. So let's move on to the time series model definition itself. There are some requirements, some critical, some less. At minimum, within your model, you will need a time key. Even in those examples where I just had a single value column, it will create its own internal time key, but typically you will have yours. It could be any data type. Sometimes it could be numeric. Sometimes it could be a date value. Just be aware when you predict, don't interpret closely the values that it gives you back. It just increments whatever it has. It doesn't know how to increment properly in most cases. Just be careful on the interpretation of what that time slice gives you. What else you will have will be predictable columns in terms of series. So you saw that I had temperature and sales. There are two approaches to doing this when it comes to setting up your data. Ultimately, you need to ensure that your training data is clean, it's representative, so outliers are removed or attended to, and importantly, that it's ordered chronologically when it's passed in. The algorithm will expect the order it's given in is the chronologic order. There must not be any missing data points. All right, so we can have multiple series. They can start ragged, but they must finish together. And there must be no missing points. If there are missing points, you either need to prepare the data by substituting them. And the other concept is that time points shouldn't be missing either. You know, if I have 12 months and I just miss one, not a great idea. If you're doing daily level and you don't operate on weekends, that's fine. Just Monday, Tuesday, Wednesday, Thursday, Friday, then repeating that cycle. But don't be irregular in the time slices that you include. Now, when you prepare your data, the columnar format says that your series will be provided as columns. You've got your time key, you've got a column for each series, and the advantages of this, it's easy to produce and to interpret, and it allows specific column types. For example, Google and Microsoft could be different data types if that made sense. The disadvantage is that if you need to add a new series, you have to change the definition of a table and the loading for it. Now, the other approach is interleaved, that says that you've got, in this case, your time key column. We've then got those column headers pivoted or unpivoted into a series column, and then we have a single data value. The advantages here is that your series names come from the data, and you can easily add new series in. The disadvantages are more difficult to produce and interpret. That's arguably not so the case. Have we seen Power Query yet? Power Query is one of those tools that will really help you to prepare your data, whether it's to unpivot it to get it into this format. The other concept is that your column types will be the same. For all the series that will use a price value, it will be the same data type for price. The characteristics of a time series model then differs from other mining models in a number of interesting ways. Unlike other data mining projects you might work on, they typically involve significant amounts of data in order to extract patterns, whereas here it could be as few as 36 if we're saying a monthly 3-cycle set of data. So it typically happens on smaller sets of data. The training data must be loaded in a particular order. The model lifetime can be ephemeral. It might be that you create it, query it, and then destroy it. Predictive values become obsolete once the time period has occurred, and we've already had that discussion on session models. Now, models may require reprocessing as new time period data becomes available. Okay, so if we predict tomorrow and then we arrive at tomorrow, well, let's just regenerate the model based on what we have. Models must be configured with drill through and accuracy testing. This is a technique typically used in data mining where we have our prepared data, we split it into a training set and into a testing set. The common ratio is 70-30%. And what you'll do is train the model on the 70% and then test the accuracy against known values to find the ratio of how often it can predict correctly. We don't have that luxury with time series because the future isn't available to us to test against. All right, so there's no such concept of holding out data for this type of problem. When you have your model processed, then we go to query it. And this is achieved with a function called predict time series. What you'll do is you'll pass in the predictable column, and then n is the number of steps that you're looking for. There are many overloaded forms of this, and we'll talk about some of this in a minute. It will return a nested table. This is a hierarchical row set. So often what you'll need to do is flatten it if your intention is to have a result that is consumable like a relational query result. Each row then in that table represents a predicted step. So here are the two queries that we could have. If it was columnar format, you would just use the column. Microsoft, give me the next 3 from my model name. And there's the flattened keyword that returns the flattened set. If it's interleaved, we're going to predict time series on that single column of price, and we'll use a where clause if our interest is just one of those series. If we don't use a where clause, you will get the predictions for each of the series that are contained in the model. Okay, so let's see some techniques in Excel of querying a model. So again, with the tools on the add-in, now that I have my models available, and by the way, if I just want to browse any of the models, here are the 5 models that I had created. My intention here is just to query the model. And so let me use the XP2, which was the 24 months. I'm interested in the next 6 steps of the sales series, not temperature. That was there for cross-predictive capabilities. If you switch to advanced, this is the DMX query, and I really like this editor. Basically click the links and there's the options and it fills in. That's the column and that's the number that I want to predict. There are a number of templates here that could guide you to a number of different things to do in DAX. Finish. What do you want to do? Let's add it to a new worksheet. And the query result comes back, including standard deviation. It's going to allow us to assess just how stable and accurate and reliable these predictions are. The predict time series function can also start from a point before the last mining model case. It's sort of interesting. -6 to 0. So it's going to use the patterns in the model, but it's going to take the cases and then predict from them. A prediction join can allow you to pass data in during a prediction. This was a capability introduced in Analysis Services 2008, only available in the Business Intelligence and Enterprise Edition. So in fact, I'll say that a fair bit, moving on, is that when you get to some of the algorithms, just the ability to modify them beyond a default is an advanced feature that's considered a non-standard edition feature. So if you really want to drive the data mining capabilities with SQL Server, you should have Business Intelligence or Enterprise Edition. When you have a prediction join, you have these 2 flags that allow you to perform some interesting scenarios. Like replace model cases specifies that the data points in the mining model should be replaced with new data. It will continue to use the patterns that it's been trained, but what it's going to do is let you sort of rewrite history and then predict into the future from the rewrite. The extend model cases allows you to extend beyond what's been used to train the model. And this can be used in certain what-if scenarios. Let's see. So with the replacing of cases, what would future sales be if I applied a different data series to it? And so this could be what we've trained the model with, and then we pass in and say, but replace the last 6 months as if it were this, and then go ahead and predict what could have happened. With the extending of cases, if we sold less in the next months, how would that impact on future sales? Again, with the same trained model, and then extending the cases and then allowing a projection to happen from there. So notice the upward trend that we had from the model, but because we're predicting or we're anticipating some decline, we can feed that in and use the model patterns to continue, but to pick up from a lower level. So let's switch across to the more professional tool set. That's not to suggest Excel is not professional, but what DBAs would likely be using. So here I am in Management Studio. And I have an example of replacing cases. So the third cross prediction that I gave you was the 3-yearly one, where we had a steep decline at the last minute that sort of skewed the results, and we saw that it wouldn't allow further predictions because it was simply too unstable. So if I go ahead and query and predict the time series of the next 3 sales from that model, you see that it actually falls out here. It says, I'm not going to give you anything because it's just not going to be reliable. And so a technique we could use is to replace model cases by using a prediction join. Now, a natural prediction join means that the columns within your join set actually match in name. If you don't have matching names, you need to use an on clause and say, well, from the model, from my input query, this is how they match. If they match by name, you can just do a natural join, and then you don't need to have an on clause. And what I have here is really a singleton query. This is just a union of the 6 months that perhaps should have been used and are going to be used to replace. So by using this technique, I can go ahead and continue to use this. And maybe this is where I probably should have cleaned the data before training the model, but using this technique, I can then say, well, this is what would have happened, then use the patterns to project forward. Tuning a time series mining model. So the discussion here is about accuracy. I mean, are we going to use the forecasts? Are we going to trust them? Do we expect that they will be reliable? So additional data mining functions can be used to determine the quality of your prediction. The basics from a statistics point of view will be predict variance, and then the square root, typically the predict standard deviation. Interestingly enough, the way that you need to query this is by using this type of subquery technique. I'm not exactly sure why that is the case, but it is. And this is the technique that you would use then to bring in standard deviation and variance. And so just a reminder for those that perhaps Statistics 101 was many years ago, what we find is that the standard deviation is a measure of spread. The more spread on a prediction, the less reliable and less confident you should be in it. So when we look at the natural distribution here, or normal distribution, one standard deviation either side of mean gives us a 68% chance or confidence, and then 95% is achieved with 2 standard deviations. So what I could do here is return to my Excel query, and given that that result gave me the standard deviation of each projection, or prediction, excuse me, I could do this. What is the lower, what is the upper range? Equals, let me round the prediction minus 2 multiplied by the standard deviation, and that would give me 78.76. If I copy that formula and I use plus, then these are the ranges that I'm dealing with. And with a 95% degree of confidence, we're likely to end up within these boundaries. I use 2, yeah. So as you see here, 2 standard deviations from the mean, or from our prediction, is going to give you a 95% confidence. Algorithm parameters. So you've seen me work with these as far as controlling the actual algorithm that's being used. Forecast method, ARTXP. Periodicity hint, 12. So missing value substitution is one that could be handy for you, that if your data set does have null values for some data points, this will be illegal. You will get errors when processing this model. You can use the missing value substitution either to set it with previous, take the previous value, the mean, take the average of either side. You can even use a constant value and say that's the value that should be used to replace. The periodicity hint is super critical, super important. If there is some cycle to your data, you need to declare that to the model. Forecast method you've seen me use. By default, it is a blend of ARTXP and ARIMA. You can, if you have business intelligence or enterprise editions, control this and say it's one or the other. And then you can take it to the next level with prediction smoothing. If you are using a mixed method, you can control the degree. So it is by default set to 0.5, which is a blend. But if you change this, then you can control either more ARIMA or less ARIMA. Okay, so that would really depend on, are we looking for more short-term attention or for a longer-term attention from this model. Instability sensitivity. So XP3 that stopped predicting after 2 steps, you could override this and say, all right, values closer to 0 will reduce the impact on instability. If I set this to 0, it'll go, good luck, you can have it. All right, so that's the taking the governor off. Minimum series value and maximum series value allows you to constrain the peak or the very bottom. For example, if sales started to predict in negative values, this is nonsensical. You might set that to some lower boundary that you would never want it to pass. So where I've arrived at this point are a couple of demonstrations that explore more deeply and by using different tool sets. So with SQL Server data tools and with script with DMX, the data mining extensions. So the first step is to prepare the data. And what I have here is 12 months of NASDAQ closing stock values for these 5 companies: Apple, Facebook, Google, Microsoft, and Yahoo. So currently we have the data sitting here in column format. I am going to use this amazing new tool, Power Query, to take this range of data. If I make this an Excel table, this then can become the source of a Power Query. So let me create a Power Query based on this data. And I'm simply going to take these and unpivot them. And I'll rename this to become the stock, and this one to become the price. So this is actually a very, very cool tool when it comes to preparing your data for your mining activities. Call these stock prices. Now, my intention is to get this data out of Excel and into a SQL Server table. So let me go ahead and open up a script that's going to be stock forecasting. I go ahead and create a new database named demo. And using this database, I'm going to create a table to store that stock price data. Now, to get the data in there, this is a technique that I sometimes use in Excel and just as well here in Power Query, is to insert a column that's going to build up my insert statement. And there's all the insert statements that I'm going to need to load that data into the table. So let me go ahead and apply this query that's going to load the result as a table into the worksheet. And then I just take this range of data, copy it, and paste it into Management Studio. And voila. So now I have a table ready to mine, and there's 1,260 rows of data. So the tool of choice will be Visual Studio. File, New, Project. The Analysis Services group of templates includes this one here, which often the windows like this, you don't notice it. But the first one is the Analysis Services Multidimensional and Data Mining Project. And so I'm going to call this forecasting solution, and this will be stock forecasting. Most commonly, this project is used to develop cubes. It's multi-purpose. The starting point is the same, just, regardless of what you're achieving here. That is to define a connection to where your data is coming from. In this case, it's my localhost SQL Server and the demo database that I just created. We'll use the service accounts credentials. Great for demos, not good for real world. And that defines the data source. The next level is to build a virtual schema that represents the data, in this case, that will be used to process our mining structures. There's only one table. There is my stock prices. I need to add them in, and we'll call that stock prices. We don't develop cubes or dimensions. We jump straight down, and we use the wizard to define a structure, and this wizard also allows us to define the first model within the structure. So using relational database data coming from our data source view, and there's the algorithms that are available with analysis services, and of course we're using time series. There is the data source view, single table, contains all of our cases, and then we configure the structure of the model. So critical is that you've got a time key, and it happens that our stock, this interleaved format or storage of data, means that stock becomes a key, and then price is what we're looking to predict. If you input and predict at the same time, that gives you cross-predictive capabilities. If you predict only, the series will not cross-predict between themselves. In Standard Edition, that's all you can do. In Business Intelligence and Enterprise Edition, the combination gives you cross-series prediction. The content types and data types, there's no need to change these. There are only 5 or 6 data types, and they map to the SQL Server types, and here it pretty much detects the continuous nature of what we're predicting. And we'll finish this with stock forecast as the name of the structure, and finish. First tab of the designer gives us the structure. The second gives us the models, of which we have 1, but of which we could go in and add new models against the structure to reuse that structure and metadata and data. Right-click the model. This is where the algorithm parameters are available. I'm not going to modify anything at this stage. I don't think there's going to be a 260-point cycle within the stock market. Does anyone disagree? It's actually an interesting demonstration, because do you really think there's a lot of value in mining stock prices like this? It's a hard one to say, but you know, the fact that a politician could go and say something stupid tomorrow has more impact than perhaps the science that we can put into it here. And if we really could predict in this way, then we'd all be billionaires. Okay, so it makes for an interesting demonstration, and sure, we might discover some interesting correlations, and that could certainly tell us something. I'm not sure I would put a lot of value in the predictions it's going to come up with. But hey, let's give it a go and see what happens. So no need to change any parameters in this case. When I right-click the project and deploy, it scripts up the definition, sends it across to the server, instantiates the new objects being a data source view, structure, model, and the default processing option is to process. Take the data from the underlying source, and the algorithm is doing its job to detect patterns and store them. That enables us to move forward to the next tab, which is the visualization of this data. This is, in fact, the same visualizations that were made available to us inside Excel. Management Studio launches them also, and as a .NET developer, these may be embedded royalties-free into your own applications. All right, so all the visualizations you see that ship and are available here in Visual Studio, you can embed into your own application. Let's focus on what's going on with Microsoft. So we get to see this, and here we can go ahead and start predicting. You know, just how accurate does it think it is? Not terribly. Let's see what it comes up with here for Microsoft. The ARIMA equation down the bottom, don't even ask me to explain this. The regression formula that we see here, interestingly enough, is factoring in Google from 8 steps ago. So it detected some sort of pattern that said whatever Google was doing, was it positive or negative coefficient? Ooh, 0.002 of Google's price should be added to Microsoft's price. From a prediction point of view, oh, by the way, I shouldn't jump over it. From an accuracy point of view, there's nothing we can do with the time series algorithm. We don't have any held out cases knowing what's coming in store. The prediction then allows us to predict against a model, which I just have the single model in this structure, and it's simply a matter of doing a prediction function. Well, in fact, what we will do, because this is interleaved, we can request the stock. Request the stock first, and then do a prediction against the stock. And here is the predict time series function, predicting for price, comma, let's just go for the next 5. And here is the hierarchical set that comes back for each of the series. Now what's been developed there is a DMX query. And DMX, many people think stands for data mining expressions. This is not correct. It's data mining extensions. They're extensions on top of SQL. So if you've already got a mastery of SQL, you're 90% a DMX developer. You just need to learn about prediction joins and, of course, the prediction functions. It's reasonably straightforward. It will always be from a single model, should involve a prediction function. And just as an example, if I removed stock from here, you know, we have where and order buys. What if we just did a where, this equals Microsoft? And then we just get the result for Microsoft. Typically, when you want to consume the results, you're going to switch this to a flattened. And there's your prediction. Now, if you're familiar with querying SQL Server tables as a developer, we have .NET, we have connections, commands, data readers. This is no different. This is just a command that will be issued against analysis services. It'll bring back a data reader, no different. So the consumption of predictions is very, very straightforward. The second demonstration then is to move on to script. So this set of data is the Microsoft closing price per month against industry sales. This is taken from the US Census Bureau. So we might hypothesize that the closing price each month for Microsoft might have something to do with the spending on electronics and software. Let's see if there's some relationship. So what I'm going to do for this one is create a table to store the data. This time, a single series for Microsoft and one for industry sales. The select statement is hidden. Did this one in advance, so it's already there. I'm going to copy this down, but notice that the last one, that we don't yet have the industry sales. They're not published. Okay, so it's obviously got a problem with the last one, and so we're going to put in null. So the question coming from here, can we do an export from, are you naming Excel here? Yeah, I don't believe Excel really has that ability to push into another store, so not really. Does anyone know of a tool? There could be add-ins that would do this, but native features in Excel, not really.
No, you can't. SQL Server uses export utility to load data from Excel from
Mm-hmm.
We normally don't use like thousands of records, we use millions of records.
Oh, yeah. So your point is taken. So what I'm hearing here is that we could have millions and millions. In time series forecasting, you're unlikely to have millions. But in those cases, you're likely to use, if you're mining that type of data, you're likely to be an IT professional or a data scientist. You're very familiar with other tools, and you're probably working directly with tools like SQL Server. And for data preparation, you might be working with, if it was Microsoft tools, like integration services and so on. So you're not likely to be using Excel. It really supports me well in a demonstration. And for time series data, it actually is a good fit, because you're often bringing in data that is time series. It's not often a lot of data. And so I'm opting to do it this way for the demonstrations. All right, so now I have this data, and we can see it here. And notably, we've got this null down here. What's going to happen? So this time I'm going to do it with script. And I think what's great about analysis services data mining is you can choose the tool that best fits you and your requirements. And here is the concept that a DBA, who's more familiar with scripts, is looking to just do everything from script to, because that's the way they work, or because it's easy to reproduce and re-execute. So this is pretty much the sequence. Visual Studio did this on our behalf through the project when we deployed. I'm going to go ahead and create a mining structure that defines the columns and types and content. Next, into the mining structure, I alter it and I add a model, and these are the flags that determine input predict or input and predict. The one that you only have in standard edition is predict only. So predict means it can be both used for prediction or as an input against another series. So that effectively means we can have cross-prediction between Microsoft and industry sales. And here is the choice of algorithm, and here is where we pass in the algorithm parameters. So I now have a model against the structure. The way that we process it, interestingly enough, is through an insert. By inserting into a structure, you're loading data, but that forces the process to then store the patterns in the model. The open query technique against a connection. So let's take a look at this. Connecting to analysis services. The stock forecasting has a data source named demo, and that is what the open query is using. And that's just a valid select statement. Importantly, there's the order by month. You must order the data as it is loaded in. And then I go ahead and insert this, but I end up getting an error. And the error is about missing data points. You cannot have nulls. Okay, so let's move on. Let's drop that mining model. Did it drop my mining model? Does not exist. And then what we're going to do is use the missing value substitution. Next, we can insert. And then we go to query the model and request the cases. I want to see the data that we're passed in. And we get another error. So I'm doing this deliberately. You must have drill through enabled for this model. So let's drop it again, alter it, and the way you add drill through is with the drill through down here. So now with the model, select the cases, but no, you haven't processed it. Insert. See the insert command here? We're not actually using an open query. The cases are in the structure. So the model is just inserting from the structure, and that results in a process. And now we can query the cases. That's the data we're passed in. And we can also query the content. So these are the model data. What you'll see here is all of the ARIMA data. And there are two nodes here of the regression formula. And so this is basically how it's made available to you, and you can then imagine this is what's stored in the model after processing. Finally, we can query it. And here's our standard query to bring back the next 12 for Microsoft, including standard deviation. So there's the script approach to data mining also. Any questions? Yes?
I wanted to, where was predicting price, is looking at previous price as well.
Mm-hmm.
Industry, right, to get that price. So it's using two. Could you add a third or fourth?
So the question is, could we add other series? Absolutely. So this could be in support of your hypothesis. It could be that you think temperature impacts on this, or you've discovered that there is a correlation between Google and Microsoft. By all means, include it because it can stabilize your model. All right, so you would then hunt around and say, well, if I think there are correlations between series, then include them, by all means.
Yeah, so we kind of need to manually play with this, or would it be smart enough to see this column isn't helping our prediction?
So the question here is about that if it discovers there's no correlation, it simply doesn't refer to it in the formula. So we saw that Microsoft and Facebook had nothing in common according to the formula that it found. Okay, so it may not have any bearing, but you may include other series for their own predictive purposes. We want to forecast Facebook as well. Okay, but if you were only forecasting Microsoft and you found no correlation, then you'd simply drop it. It's not worth continuing to collect and maintain that data. All right, let's take a look at another question here.
So, I like the part that you can predict from previous numbers, but like what if there are additional parameters that are coming in?
Okay, so I think you're referring to the replace model cases example. What happens with those flags is they do not change the patterns that are in the model. What I think you're about to describe to me is that you have other data you think could be helpful. That's a new model and a new process. The concept of those flags is to reuse the existing patterns, but to influence the cases or to extend the cases. Okay? The important thing to understand is it is not retraining the model. It is continuing to use the patterns that it has. All right, some business scenarios then. Consider any scenario involving the need to know what is likely to happen. Extend trend analysis with this what could be. Seed planning for forecasting. Instead of just jumping in last year's numbers multiplied by 10% increase, perhaps look to see if there's some pattern that could be used to seed values based on a forecast and a bit more science. Embed forecasts into applications. So it's really cool when you see a dashboard and you see the sales trend, and then you can say, well, this is what the next 5 steps could be. You could also include the standard deviation in there to give some indication of how stable that prediction is. There's also the concept of CLR objects in SQL Server. And so that leads into a demonstration whereby I'm going to allow a SQL Server user-defined function to perform data mining on our behalf so we can query it readily within the relational engine. So for the IT professional, there's this opportunity to blend data mining into everyday activities. You know, what are the performance counters doing? Is there a pattern in there that might indicate something to me? Across time, this could be a way of projecting what future disk storage could be and allow us to better justify capital expenditure. All right, so there's all these types of scenarios that it's open to. Let's take a look here at an example of using a SQL Server user-defined function to perform the data mining for us. And I found this to be useful because if you're using reporting services to forecast and you want to have a chart that shows the history you have and then the ... these are the future lines, you can't do it. The reason for this is in a single DMX query, you cannot bring back both the content and the forecast at the same time. They would have to be 2 separate queries. And in reporting services, you have a one-to-one relationship between a data visualization and a data set has a one-to-one relationship with its data source. So here is an example that brings it all together as a single set of data, and let me show you how it can work. This time I'm using my favorite database, AdventureWorks. I start by creating this view that gives me a month key, category, and sales. Let me run the view so I can show you what it looks like. So basically, it creates that category column that are the 4 categories and the time key here and the aggregate of sales for that month. Need to do a bit of DBA work here, so switching across to the master database, I am going to set trustworthy on and authorization to myself in order to work with CLR functionality. Next, and in this particular case on this virtual machine, I need to register some assemblies in the global assembly cache. So I have a script that's going to do this for me. Done. And then I can proceed to switch back to the database and to create assemblies. So there's 3 here that are required. The one that I'm primarily interested in is the ADOMD client. That's ActiveX data objects for multidimensional that encompasses the data mining feature set as well. It has dependencies to others. I don't know why system.drawing is there, but you just need to do this. So when I create these assemblies, they are being loaded into SQL Server, and then I'm going to load an assembly from a project that I've already developed. So let me show you this VB.NET project, all around producing a table-valued user-defined function. The heart and soul of it is here. It's not for the non-developer. I'm just going to collapse some helper classes, but the thrust of it is this. Here is the logic for a monthly category sales forecast. that will expect a forecast year, a forecast month, and the number of prediction steps that you want. Here it is querying the view that I just created for anything less than the time period that you're requesting. So typically what you're going to pass in is the current year and month. It retrieves this, and then it moves forward and defines all of the DMX commands. And notice the keyword session being used here. That every time this table-valued function is executed, it's going to create a session structure model. And the way that it passes data in is very interesting. You can pass the training cases in through a parameter, being this data table coming from SQL Server. And ultimately, here is the query that's going to retrieve the prediction results, including standard deviation. Ultimately, what it does is drop the mining structure. And I should point out also that it uses GUIDs to name structures and models. So there's no collision should there be other people querying at the same time. So with all of these commands in place, a connection then is made across to analysis services, and then it executes. Create the structure, create the model, and here we are adding in the parameter for the training cases, process the model, and then we query and bring back a data reader. And then it simply adds these rows into a list object. We then close the data reader, we then clean up, drop that session, and then I go and add in all of the cases that came from SQL Server. So we're getting a combined set, predictions and cases together. I sort them, and then it returns the results. So if I build this, that produces an assembly, and then I can switch back here and load that assembly into AdventureWorks. I can then create the function that matches, and then I can query it as simply as this. So it's of interest to note, let's put on Profiler and watch all that goes on just with one request. So connecting to analysis services, then I go ahead and query. And here comes back in chronologically ordered. There are the cases that we use to train the model. And then ultimately come in the predictions and standard deviation. This is a lifesaver. If you're trying to bring all this back for the purpose of mapping, this is going to be very helpful. Switching across to Profiler, here's all of the activity that went on with that query request. Create mining structure, alter it, add the model, insert. And then we should have, after all the processing takes place, we have our query. Where are you? Here. And then we drop the model. So this then opens up the opportunity to use tools like reporting services very easily. Let's just use the chart wizard, define a connection across to the AdventureWorks database. To construct the query, I'm going to use the text editor and copy in this. Express that as a line. And the way that it works is that date will be your category. And what do we have? Sales and sales history will be the values. And category here means bikes, clothing, accessories, will become the series. All of these templates are very unexciting. Let's go for the least offensive. Make this large enough. And then when I run this, it's now reporting services via a data set that is making that query, that in turn is querying, creating the data mining model, and so on. Yeah, question.
Can you combine SQL and DMX? Could you select your history and then union it with your DMX?
So the question here is, can you combine a SQL and DMX? No, you can't. Otherwise, that problem would be easily solved. Okay, so the way that you might achieve it beyond SQL CLR is that you would have a process that would first query, so all in DMX, query, bring back the cases, query, bring me back a prediction result into the one table, and then you'd query that table. So here it is, the concept that we could use programming with ADOMD client, parsing DMX, and .NET logic to assemble a single set and to emit it is a lot of work, but it solves the problem. It's very, very convenient once you have this. Okay. I am running a bit ahead of time, so I'd like to just show off a very new feature about forecasting that doesn't actually fall under the topic of analysis services, but it's certainly new in Power BI. In fact, it was announced last week, and it's just been made available. So what I'm going to do is switch back to my Excel example, and what I have here, is this the one that I should use? Let me think. Stock prices, yeah, probably this one. Let me take this set of data and clean it up. I'm just interested in Microsoft. So what I want to do is bring in the Microsoft series and also the Microsoft forecast. So I can achieve this within Excel. Under data mining, I query, and we'll find that I've got on a different database. So let me create a new connection, this time to the demo, I think it was, or the stock forecasting. And now that I've connected to it, I can then query from what I have there. So it's the Microsoft forecast. Let me go ahead and predict the next 6 of Microsoft. And let's put them into a new worksheet. Okay, so I'm going to take these values and just paste them in down here. And it thinks that they're text, I'm not sure why. Convert them to numbers. And to just project the dates forward, I'm just going to copy this range down. And I'm also going to copy this to here. And actually, no, I won't. I'll show you what happens when you don't. Now, if I make this into a table, I can then go ahead and perform a Power View report on top of it. Let's see what this data looks like. Okay, let's make this into a line. So it detects that there are 2 series there. The gap there is what I was about to fix, and the fix would be you would copy the last known value and paste it in to become the start of the forecast, and then that should fix the problem. Doesn't want to? Refresh all. Excuse me. Okay, now it's caught up. All right, so there's a way to bring them together, but that's been me copying and pasting into a single range. What I'm going to do is add this again. So how am I going to do this? Let's put them side by side. This line here is just a single series, and that's important. So note this, it's date, and it's actually a date type, and there's the Microsoft projection. Let me kill the title here, and now I'm going to publish this up to a Power BI site because there's a new feature that's pretty cool when it comes to forecasting. What I'll do is I will come to the browser view options. I'm only going to publish the Power View sheet, and I'm going to do a save as, save this to my D drive, and now I'll switch across to the Power BI site and I'm going to upload that document. And then launch it. So it's a single Power View sheet. It's not driven live against any data mining. It's just based on a range of data in a table. And here it is. And if you switch across to the HTML5 view, there's a new capability that you won't know it's there until someone shows you. And it's this concept here of analysis. Do you see this line? That with a single click, it's done forecasting across that single line. There's 9 steps into the future. So how does it compare to, well, the 12 steps that are here? Actually, if you think of it, that's up to about this point. It's reasonably on par. This is a new feature added last week or announced last week and made available. Power BI service only. You must switch to HTML5. At this stage, it must be a single series with a true date type that it's running against. It's using a different algorithm. It's not analysis services. It's using exponential smoothing is the technique that's under the covers. And now this is super cool because this gives you the ability to also set the periodicity. So it's 12. You can then specify your confidence interval. So is that showing up? 1. Well, what's supposed to happen is that you see a gray area here showing you the plus or minus standard deviation. But then this gets super cool like this because, hold on, this outlier here, maybe what should have really happened, where are you, is that value should have been up here. Okay, it doesn't seem to want to work. You're supposed to be able to take this, there it goes, and say, but that's really what would have happened. Come on, up to there. Okay. I'm pretty sure that I can drag. Well, first of all, I think it was just delayed. Do you see here the 2 standard deviations? So it's giving you an idea of where it becomes less stable. And then you might say, well, really, what should have happened here? Come on. You know, something's just gone a bit weird. I just want to reload the page, if you don't mind. You can make corrections, is what I'm heading to. Switch back to HTML5. Perform the forecast. Here is the problem. There we go. And it should adjust its forecast based on that, and indeed it does. So this is where it's all heading. This is not analysis services time series that was the focus of this session, but here's a great new feature that's been built into Power BI through the HTML rendering of Power View, providing you've got that line, single line against a date value. Let's wrap up with a summary. The time series algorithm then, I hope you can now appreciate more fully, is used for forecasting. Choose the tool that fits your skills and requirements. You've seen examples with 2 different add-ins in Excel. SQL Server data tools, Visual Studio for producing a project, check it into source control, manage the entire lifecycle of your data mining project. Pure script with DMX or .NET programming, whether it's embedding into applications and user interfaces, or as you've seen with a SQL CLR, an object that can then be used to query your mining model. Algorithm parameters can be configured to tune the mining model for improved accuracy and reliability. And developers then can embed forecasts into applications to create a new generation of intelligent application. From a resources point of view, I'll leave these for you. I think you've got access to the presentation here at the event. Standard from Microsoft, you've got the SQL Server Data Mining community website. There's some interesting resources and labs and tutorials to work with there. Implementing smart reports from the BI platform, that CLR stored procedure, or the example given here of a stored procedure is documented. The main publication when it comes to SQL Server data mining is this one here, Data Mining for SQL Server 2008. Don't be discouraged by the 2008. It hasn't changed. SQL Server has not updated data mining since that release, so it's pretty much current. If you were interested in Octopi for predictions, I give you the Wikipedia site for Paul. Otherwise, we're just back to the standard track resources. I don't believe there are any other resources at this event for data mining. There are no labs, there are no other sessions. Pretty much, we much appreciate your feedback, so please take the time and effort to produce the evaluation. It tells us how best we're meeting your needs. So very much wish you the best with that and all of your forecasting activities. Thank you. Model. So when you think of tables in relational databases, it's obvious, tables store rows. In the data mining world, models store patterns, and these become the queryable resource either for exploration and information discovery, or, as our purpose is in this session, for prediction purpose. When it comes to predicting them, we have the query stage. We could take data and pass it in, and the engine will use those patterns to come out and say, these are the future values. And we'll work through this process a number of times in this session. So, the big picture, time series with analysis services. Let's take the big picture and say, well, analysis services is a product concerned with data modeling and data mining. There are, in fact, two components. And most of us, when we hear about analysis services, we're referring to it as far as cubes or tabular models. Its lesser known brother is the data mining engine, and it comes with 9 algorithms. These allow you to discover patterns and to perform predictive analytics. We'll focus on specifically one of the 9 algorithms, which is the time series algorithm. So be aware that much of what I've got to present today, I could have talked about 8 years ago. Nothing much has really changed. And so we first saw the time series algorithm delivered with SQL Server 2005. What had changed in the next release with SQL Server 2008, we still have the same algorithm, but there are actually 2 machine learning algorithms under the covers. We'll talk about these both. ARTXP for cross-series prediction and the ARIMA. The algorithm then detects patterns and allows us to predict future steps within a time series. So let's start with a demonstration of how it could work in the most basic form. Here I am in Excel with a set of data, I guess, coming from an ice cream company. We have monthly values for sales, 2 series here, strawberry and chocolate. And what I'm going to do is take this range of appropriate, configure this, and perhaps as a Excel user that's not a data mining specialist, this might throw them, but I guess they'd work out that their data is monthly, and so monthly would be the right selection to make. Simply by clicking Run, it sends commands across to that session database to create session structures, models. It copies the data and passes it in. The passing in is really a process that involves the detection of any patterns, and then it returns with a query result that first of all extends the table. I don't know why I have this empty row. Let's delete that. So effectively, there's the next 6 months that we might expect, and then it adds a bonus here with a chart showing us the projected values that could happen. So that's the very first introduction for those that are looking for an easy way to get involved with forecasting. Just collect your data in Excel, assemble it as a table, install the add-ins, and mine direct within Excel. With a focus on the first of the 2 algorithms, the autoregressive tree with cross-series prediction. This was the first algorithm that was delivered in 2005. What's pretty cool about this algorithm is the cross-prediction capability. That where you have multiple series, there could in fact be influence across them. For example, chocolate sales go up, strawberry sales may go down, and so it may detect patterns between the series themselves. This concept is unique to Microsoft's implementation of the autoregressive tree. It's considered to be a reasonably accurate algorithm for short-term prediction. So the way that it works is it uses past steps, and when it predicts the next step, and then the next step, it may, in fact, at some point start using predicted steps. So it's predicting based on predictions. So very quickly, it becomes unstable. So we use it typically for short term, the next 1, 2, 3, 4 steps. Let's take a look at it in demonstration. Data, and make it an Excel table. And when I do this, we'll see that this Analyze tab highlights. This is because I've downloaded and installed the SQL Server data mining add-ins. And this particular add-in enables the mining of data in a table. So if you have a table in focus, you have the Analyze tools. Now be aware that Excel doesn't have a data mining engine. It does require analysis services somewhere on the network. And so as the administrator, I would switch across, connect to analysis services, and I'm going to go ahead and create a database for the purpose of the mining activities that will take place from Excel. So this is simply a database, and I'll point out also, as an administrator, that I have configured here a property that's called allow session mining models. The reason for this is that this tool uses session objects. What that means is for the lifetime of a session, we can create, and then when the session dies, so do the objects. And that's actually quite fitting for time series because often when you've achieved the predictions, that model may not be worth much more when you move to the next step in the future. You then create a whole new model based on the current values and the history that you've got and produce an entirely new model. So with that database now available, here in Excel, I'm going to connect to that instance and to the session mining database. And now with the table selected, of all of the commands I have here, the one relevant in this session will be to perform forecasting. And what I like about this add-in that makes it really approachable to the average Excel user, it doesn't even mention data mining anywhere within the user interface. It's simply which columns do you want to forecast, how many steps into the future are you looking for, is there a timestamp, and the periodicity. I'm going to talk about this one. It's actually quite critical that you wear advice, I think, by using clairvoyance. More recently, we see mollusks enter the domain. And with the freakily accurate predictions that were made in the last World Cup. So we're not really here to talk about these techniques. I'm sorry to disappoint anybody. If you are interested in these, they're probably another session, most likely in a completely different conference. Because here, we're here to talk about information technology and how sound machine learning techniques can guide us and provide us with some concept of what could happen in the future based on what has happened in the past. So let's put that definition forward, that the time series forecasting is about developing data mining models to predict future values based on previously observed values. So if you ever find yourself in the situation where you need some idea about what could be happening, you might look towards a clairvoyant or a mollusk or even your own gut instinct. But perhaps it's better to support your gut instinct with some scientific reasoning and then make a choice or maybe blend the two together. Here's an idea of what we could achieve. There's sales, the cyclical pattern that's happening over a couple of years, and via a detection of patterns within that data, we can put forward what could happen in the future. Let's see how it happens. So there's no prerequisite that you have any background in data mining. Let's start with the very fundamentals. When it comes to producing a data mining solution, first of all, you need to understand the business problem and then design a model to help you with that. And a model is defined in terms of an algorithm that is responsible for detecting patterns. You have inputs and outputs. So in a time series, your input's going to be sequences of time and snapshots like sales values that have occurred each month. We then process the model. That means taking carefully prepared data, our sales history, and then it gets passed through the data mining engine that is responsible for detecting and then storing the patterns in the. So it's a good afternoon and welcome. We're here this afternoon to talk about forecasting with the Microsoft Time Series data mining algorithm. My name is Peter Myers. I'm a business intelligence expert. I'm an all-rounder, and data mining often catches my attention, and I look for opportunities where I can do much more on a project by delivering back to the business some insights and perhaps even predictions on the data that they're currently collecting and managing. Brief background about myself. I don't work for Microsoft. I'm in fact a SQL Server most valued professional. I have been for the past 8 years. I've traveled from Melbourne and I spend a lot of time these days in training, education and awareness around Microsoft Business Intelligence products. Feel free to connect with me on LinkedIn, or if there are any questions that I don't address during this session, and I would hope that I do, by the way. My style of delivery lends itself well to interactivity, so feel free to inject a question as and when it arises. What we're here to discuss today is what data mining is about, but specifically machine learning processes concerned with forecasting of time series. I'm going to give you a whole set of demonstrations that show you what you can achieve from working with Excel, working with Visual Studio as a developer, working with Script as an administrator, and maybe even as an application developer working with code. We'll look at how we can tune a time series model, and we'll describe some business scenarios that could inspire you on how you could apply these techniques. So I thought a good place to start would be the very history of forecasting. Take a moment to absorb this one. A favourite artist of mine from Melbourne. So an interesting sense of humour here. So from the dawn of time, cavemen themselves were thinking about what could be in the future. Perhaps in more recent times, we see businessmen attending the services of these folk. I'm aware that certain political leaders have been known to get